So this time we're going to use another method of adding vectors, what we call the analytical method. So in this method, instead of using ruler, protractor, and graphing paper, we're going to use the basic concepts of algebra, trigonometry, and geometry. But some rules of adding vectors graphically will be used here, since vectors are still represented by a line. Alright, so suppose these are two given vectors. Vector A, whose magnitude is 5 meters and it's 45 degrees from positive x-axis, and vector B is 10 meters, 110 degrees from positive x-axis counterclockwise direction. So we're going to draw that this is vector A and this is vector B. Okay, we're not going to measure the line from the tail of the first vector to the head of the last vector, since we're not going to use protractor ruler here. Okay, now vector R represents the sum of two vectors. Now if I'm going to extend this line, and these two lines, both x-axis are parallel to each other, so it means we have corresponding angles. It is cut by transversal. The parallel lines is cut by transversal. So if this is 45 degrees, this is also 45 degrees. Corresponding angles are congruent. Now, if I will extend the line here, alright, we form a straight angle, and straight angle measures 180 degrees. Now, from positive x-axis to vector B is 110 degrees. Then, the measure angle here is 70 degrees, right? 70 degrees, since the sum of 110 and 70 is 180 degrees. We have a straight angle here. Alright, now if we're going to add 45 and 70, then this angle is 115 degrees. Right? Now if this is 115 degrees, the opposite angle or the vertical angle is still 115 degrees. Vertical angles are congruent. Okay? So these are the vertical angles. So if this is 115, this is also 115 degrees. So we can now solve for the magnitude of vector R. Since we have the opposite angle for the unknown side, this is, we form a triangle. R here is the unknown side, and then these two sides are known, which is equal to its magnitude. So we're going to use the cosine law to determine the magnitude of vector R. So the square of R is the square of magnitude of A plus the square of magnitude of B minus 2AB cosine of the opposite angle of R, which is 115 degrees. Then this is 115 degrees, or the magnitude R equals alright, and then R equals the square root of magnitude of A, which is 5 meters, so that's the square of magnitude of A, so that's square of 5, plus the square of magnitude of B, so that's 10 squared minus 2 times 5 times 10 times cosine of 115 degrees. So R equals, so let us use solve. So let us solve using calculator. I have vector R equals 12, magnitude of vector R equals 12.93 meters. Now how about the direction of vector R? Now, vector R, the direction of vector R must be measured from positive x-axis in counterclockwise direction. So That's positive x-axis to vector r. Now, how can we solve for this angle? How can we solve the direction of vector r? If we're going to add 45 degrees plus this angle, I'll mark that as theta of b since that's opposite of d, vector b. Now if we're going to add 45 degrees and theta of b, that's the direction of vector r. So we have theta as the direction of r is theta of b plus 45 degrees, which is the direction of vector. 45 degrees is the direction of vector A from positive x-axis in counterclockwise direction. Alright, but what is this vector B, theta of B? We're going to use Sine Law. Right? Sine Law. R, since this is now given, we know already the length of R, which is 12.93 meters. So that's R divided by the sine of its opposite angle. That's 115 degrees. Sine of 115 degrees, which is equal to the known side, which is 10 meters, and that is the magnitude of vector B. That's 10 B, putting B over sine of its angle, and this angle is unknown, so we have sine theta of B. Okay, or sine of theta of B equals B sine of 115 degrees all over R. Or theta of B is the inverse sine. It's the inverse sine of B sine of 115 degrees over R. So that is the inverse sine. B is the magnitude of B, that's 10 meters. We have 10 meters sine of 115 degrees divided by R, the magnitude of vector R, which is 12.93 meters. Then this is 12.93 meters. Okay, so we're going to use again calculator. So theta of B is 44.5 degrees. So this angle here, theta of B is 44.5 degrees. 44.5 degrees. So we have the direction of vector R, which is 45 degrees plus 44.5 degrees. Alright? So theta of B is 44.5, then this is 44.5 degrees plus 45 degrees. Then we have 89.5 degrees. So we have the magnitude R and we have theta as the direction of vector R from positive x-axis in counterclockwise direction. So vector R equals 12.93 meters, comma, the direction 89.5